In this video, we'll take a look at factoring the difference and also the sum of two cubes. And these are the two factoring patterns at the top of the page here before we get into four examples. I just want to demonstrate that they actually do work. If you remember, if we go from in this direction to this direction, that's factoring. If we take this and expand it out, or expanding or multiplying to get back to this is called expanding. So factoring, expanding, or factoring and multiplying are opposite operations. And so we're going to take the factored form and multiply it together. And so first I'll take this x and distribute it into the trinomial. So x times x squared would be x cubed. X times ax would be ax squared. And x times the a squared would be a squared x. Next we'll multiply the negative a into the trinomial. So negative a times x squared would be minus ax squared. Minus a times x would be minus a squared x. And negative a times a squared would be minus a cubed. So I'm just again trying to demonstrate that this does expand to give us x cubed minus a cubed. Now this term and this term are opposites, as are the a squared x and minus a squared x. They're opposites. And so all that adds to 0, and we just get x cubed minus a cubed. And so that demonstrates that these are the two factors of x cubed minus a cubed. So notice when you're factoring the difference of two cubes, whatever is being cubed here and cubed here, x minus a in this case, x minus a is one factor. And then the trinomial factor is what's being cubed here, which is the x squared. And then the product of the a and the x, and then the a squared on the end. Notice if it's the difference, then this is x minus a, but there's a plus in the middle. Okay, so this sign for both factoring patterns is always the opposite of this. If it's x minus a, then it's plus. If it's an x plus a, there's a minus in the middle here. So the sum of two cubes, if you remember factoring the difference of two squares, the sum of two squares, well, just about never factors. For all intents and purposes, it doesn't. But the sum of two cubes does factor. Okay, so both the difference and sum of two cubes factors. So x cubed plus a cubed, one factor is x plus a, and the other factor, and notice how similar this trinomial is to this one. The only difference is the sign in the middle. But again, this sign is always the opposite of this. So it's the sum of two cubes, the binomial has the plus, and the trinomial has the minus in the middle. Otherwise, this term really is very similar to this one. So if we expand the x into the trinomial, x times x squared would be x cubed. X times minus ax is minus ax squared, and the a squared x comes from multiplying the x by the a squared. Next we'll multiply the a into the trinomial, and so a times the x squared would be ax squared. A times this would be minus a squared x, and the a cubed comes from multiplying the a and the a squared. Just like over here, this term and this term are opposites, so they add to 0. A squared x and minus a squared x are opposites, so they add to 0. And we just get x cubed plus a cubed. So just demonstrating that these are the factors of x cubed plus a cubed. In the example, we're asked to factor each of the following completely. And so in each case, I'm going to write the difference or the sum as in cube form. So x cubed is a perfect cube, but 8 isn't really written as a perfect cube. It is a perfect cube, but it's 2 cubed. So I'll write it as the 8 as 2 to the power of 3. And so the difference of the two cubes, x minus a, which in this case would be x minus 2, is going to be one factor. And the other factor is going to be, well, actually, I'll write it out first, I guess. Just comparing it to the x squared plus ax plus a squared. So it's the beginning part here, the x squared, the product of the a and the x in the middle, and then the a squared in the end. So in this case, it would be the, well, look right here, x squared, 2 times x in the middle, and 2 squared in the end. Remember, this sign is the opposite of this. So it's x minus 2, it's going to be a plus in the middle. The only thing I would do to simplify this is square the 2, and so everything else the same, we'll just write that as 4. So x minus 2 and x squared plus 2x plus 4 are the two factors of the difference of two cubes, x cubed minus 8. In B, 27y cubed plus 64k cubed. So writing in this case, the sum of two cubes, 3 cubed is 27, and of course y cubed is y cubed. 4 cubed is 64, and if we cube the k, we get the k cubed. We got a tongue twister there. So the 3y plus 4k would be the binomial factor, 3y plus 4k. And then in the trinomial, we'll start with this squared, end with this squared, and then minus the product of them in the middle. So 3y squared minus the product of the 3y and the 4k plus the 4k squared in the end. So that's really the x squared minus ax plus a squared trinomial, the x squared minus ax plus a squared on the end. So we would want to simplify this trinomial. So we'll leave the 3y plus 4k alone. And we'll just let it come out. There we go. So if we square 3, we get 9. And of course, y squared is y squared. 3 times 4 is 12. And k times y would be a ky. So minus 12ky in the middle. 4 squared is 16. And of course, k squared is k squared. So those are the two factors of 27y cubed plus 64k cubed. Now in C, 250 and 16 are not perfect cubes. But whenever you're doing any factoring, always look for a common factor. And there is a common factor of 2 in both of these. So we can factor a 2 out of both the 250w to the 6th and the 16p to the 12th. So we factor a 2 out. 2 out of 250 gives us 125, and 2 out of 16 gives us 8. Well, this is now a perfect cube, and of course so is the 8, just like it was a perfect cube over here. So to write this as the sum of two cubes, don't forget about the 2. Leave the 2 in front. So 5 cubed is 125. You can find what that number is by taking the cube root of 125. And it would have to be w squared in here. Remember, power of a power rule. You multiply the exponents 2 times 3 to give you the 6. And of course, we want it to be a perfect cube. That's why the 3 is out here. 8 as a perfect cube is 2. So 2 cubed gives it the 8. And it would have to be a p to the power of 4 here for 4 times 3 to give you the exponent of 12 here. So that's how I would write that as the sum of two cubes. So the 2, don't forget the 2 has to stay in front. So we'll have a 2, and then the binomial will be 5w squared plus 2p to the 4th. Now the trinomial will be this squared in the end, and then since it's the sum of two cubes, minus the product of them in the middle. And this is what it looks like. So again, 5w squared at the beginning, minus the product of these in the middle, and then plus the 2p to the 4th squared in the end. So let's simplify what that is in the trinomial. Write it down the first two terms first. So 5 squared is 25. W squared squared, 2 times 2 gives you 4 here. Minus 5 times 2 is a 10 here, so minus 10. And then w squared p to the 4th. And then 2 squared is 4. P to the 4th squared, remember, you power of a power rule, you multiply the exponent, so that's why it's 8. So those are the, well, 3 factors, because there's a common factor of 2 here as well, from this original binomial. For D, 64 is a perfect cube, and of course, the powers, as long as you see in the exponent is divisible by 3, like 6 is divisible by 3 and 12 is divisible by 3, then it's going to be a perfect cube. Because when we go to write it as a perfect cube, you see we can divide that 6 by 3 to get 2, or the 12 by 3 to get the 4 here. So I want to write this again as the difference of two cubes. So it's 4 that you would cube to get 64, and it'd be x squared that you would cube to get x to the 6th. The cube root of 729 is 9. And 9 cubes that. And of course, y to the 4th cubed would give you y to the 12th. Well, so this is a difference of two cubes. So the binomial factor will be this minus this. So write 4x squared minus the 9y to the 4th. And then in the trinomial, so it would be 4x squared squared. And then plus, because it's a difference of two cubes, so it has to be a plus here, plus this times this. And then plus the 9y to the 4th squared in the end. So we want to simplify the trinomial, of course. So 4 squared is 16, x squared squared is x to the 4th. 4 times 9 is 36, and x squared y to the 4th. And then we would have 9 squared is 81, y to the 4th squared is y to the 8th. Now, it says factor completely. This is actually the difference of two squares. So if you remember the difference of two squares, that binomial will factor. See, you could actually write the 4x squared, you actually could write that as 2x squared. And then the 9y to the 4th, you could write it as 3y, that's a y there, y squared squared. So that actually is the difference of two cubes, or sorry, difference of two squares. So it would factor, so that would factor into 2x minus 3y squared and 2x plus 3y squared, and then we'd have the trinomial on the end. And it really doesn't matter which of these you put first. If you want to put the plus first and the minus second, it doesn't matter. And of course, the trinomial would stay the same. So you were asked to factor completely. That's why we would also use the difference of two squares factoring pattern here to factor that into its two binomials. And that's the end of the video.